Good morning, good afternoon, or good evening, depending on where you are in the world. My name is Sharon Florentine. Welcome to today's DevOps.com webinar, 4 open source tools that will change how you manage Kubernetes, brought to you by Fairwinds. We have an awesome webinar for you as always, but before we get started, I need to go through some housekeeping items with you. Please be reminded that the session is being recorded, so if you miss any or all of it, you'll be able to go back and watch it again. We will send you an email with instructions for how to access the webinar on demand, and you can always visit us at devops.com/webinars. It will be there for you as well. We are taking questions throughout the presentation, so don't wait, don't hesitate. Get your questions in early and often. We will try and get to as many as possible at the end of the presentation. What we don't have time for, we'll round up, send over to our presenters today. They will be able to follow up with you offline. And stick around until the end because we are doing a drawing for 4 $25 Amazon gift cards. So stick around and see if you are a winner. Finally, we're going to have some polling questions for you today. So when you see those pop up on your screen, we would appreciate it if you could take a couple seconds and submit your responses to us. That would be great. All right. With that, I am pleased to introduce to you today Robert Brennan, Director of Open Source at Fairwinds, and Andy Suderman, who's the Director of R&D and Technology at Fairwinds. And with that, I'm going to stop talking, put myself on mute, turn my camera off, and I will let you gentlemen get right to it.
Cool. So today we're going to talk about open source tools that can help you manage your Kubernetes environment. We've got a handful of tools that we manage, and we'll tell you about how to use them. So I'm Robert Brennan. I'm Director of Open Source here at Fairwinds. I've been working in software for a little over a decade and in open source for about 6 or 7 years now.
And I'm Andy Suderman, Director of R&D and Technology. I've been with the company for about 3.5, been doing Kubernetes for 5, and I've been in ops for about a decade.
Well, so just a little bit about our company, Fairwinds. Fairwinds provides both services and software really to help folks run Kubernetes with confidence. We provide commercial software that will basically help examine your Kubernetes environment and show you how well you're doing from a security perspective, an efficiency perspective, and a reliability perspective, and take action on those findings. We have a suite of open source software, which actually drives that commercial software. And then we have a bunch of professional and managed services where you can actually work with some of our Kubernetes experts hand in hand to build and manage Kubernetes clusters.
All right, folks. So like I said, here is our first polling question for today. Where are you in your Kubernetes journey? So if you could take a second and let us know if you are learning about containers and Kubernetes, if you are planning to use in the next 6 to 12 months, if you are using only in testing or dev environments, if you're using it in production, or if you have no plans to use it. So I would assume, Robert and Andy, that we're not going to get very many E responses if people are tuned into this this webinar. But, you know, it looks like I am wrong. That's the first time ever. All right, I'm just going to let these responses roll in for a couple more seconds. And now I'm going to close that poll and let you know what everyone said. We have 29% of respondents are learning about containers and Kubernetes, 8% planning to use in 6 to 12 months, 20% use only in test dev, 40% are using it in production, and that one lone respondent with no plans to use. Proving me wrong. Well done.
Cool. So the first problem we want to talk about is about really validating configuration, the workload configuration that's going into your cluster. A lot of times in Kubernetes, the defaults are not necessarily the best configuration. There are some default security settings that are a little too permissive for most workloads. And there are also other default settings or settings that can be omitted, and Kubernetes will happily take in that workload, but it won't be able to self-heal. It won't be able to manage its workloads as effectively without those settings in place. So our solution here is a project called Polaris. Polaris comes with 20 built-in checks for common issues and best practices. It also supports creating custom checks using JSON schema, which is a schema language that Kubernetes actually uses under the hood to validate all the resources that come into the cluster. So if you have an internal labeling scheme or some other internal requirements about like which registries are being used for Docker images, you can encode those in custom checks in Polaris. And Polaris can run in 3 different modes. It can run as a dashboard looking at the resources in a live cluster. It can run as an admission controller, basically serving as like a bouncer for your cluster and rejecting any resources that would break your policies. Or it can run as a CLI so that you can audit your infrastructure as code at PR time and basically stop PRs before they break anything. And then I think Andy has a demo of Polaris ready for us.
I do. Thanks, Robert. So I have here, I'm connected to a Kubernetes cluster. We can take a look. We can get nodes, just see that I have some nodes in this cluster. Particular to node, I have a few different workloads running, but in a namespace called basic demo, I have just a simple demo application running in the cluster along with some ancillary services to go along with it. So if I wanted to run Polaris, as Robert mentioned, there's a few different ways we can run it. The first way you might want to do it is just to install it in your cluster and then look at the dashboard that we provide. So what I would do is a Helm upgrade -- install. In this case, I'm going to use this because I've actually already installed it. We're going to install Polaris from the Fairwinds stable repository, the Polaris chart. Pretty straightforward. I want to put this in the Polaris namespace because I want to keep it separate. And just in case that namespace doesn't exist, we'll tell Helm to go ahead and create that namespace. So this will take a few seconds. We'll go get the chart out of our stable repo. And then you're going to get some instructions here. So if you want to take a look at that dashboard, you want to not have to deal with ingresses and stuff like that, we can just port forward straight to the dashboard. There's a service in the Polaris namespace now called Polaris Dashboard. So I will port forward to that. And if we pop over to our browser here, go to localhost 8080, I'll go ahead and give that a quick refresh. We see the Polaris dashboard as it applies to this particular cluster. Give that a second. All right. So we're going to see over here, it gives us just a general grade and a percentage. This is based on the number of checks that are passing versus checks that aren't passing. So we have some things going on here. We've got 34 things that we've defined as dangerous, 128 warning. We have different scores based on the different categories. Security is our worst score. That's unfortunate. But I start looking at these and I realize that there's a lot of namespaces here. And as the developer that just deployed this demo application, I don't want to see all this. Like I don't run the AWS IAM Authenticator. That's my ops team's problem. So I'm just going to click on this filter option, or maybe I am the ops person and I just want to filter one of the others, but I'm going to filter to this basic demo namespace and hit apply. And we should see a much different dashboard, a lot less going on here, less numbers, yay, things that I can actually focus on here. So now we're getting a B- score. We can scroll down and see, security is still our worst score, reliability is there, but our efficiency is at 100%, so that's great. And now I want to know, why am I seeing these numbers? What do these actually mean? So if I scroll down, I see my namespace. I see I've got a deployment, an ingress, and a PDB that Polaris has picked up on. And so I'm going to open up this deployment, and I'm going to see what different checks are wrong here. So we see, we've got a possible privilege escalation problem. Well, what does this mean? How do I mitigate this? So I'm going to click on this little bubble here, and that'll take me over to the documentation site where we have a list of all the different security, efficiency, and reliability checks. This is probably a little small for y'all. And we can look and see, what's going on here. So we see privilege escalation allowed, fails when security context that allow privilege escalation is true. Great. So by default, Kubernetes sets this privilege escalation flag to true. So I really need to take a look at that and go set a security context in my deployment. It turns out, actually, I think most of these are related to that particular block in the YAML, but another one here, image tags should be specified. We're running the latest image. We should be pinning specific tags. So that's the Polaris dashboard. It's probably the quickest and easiest way to get a visually pleasing Polaris experience. It's also nice because it runs all the time, so you can go back and check it later and see, if you're improving over time. The second way that we can run Polaris is as a CLI. So Polaris, on our GitHub page, there's a download. You can just download a binary. It's written in Go, so you can just build that binary if you want to. And so we have this command called Polaris audit. I'm just going to run that against this cluster. I already showed that I'm connected to the cluster. So it's going to pick up on that, and it's going to run the audit. And we'll see in the CLI, if my firewall lets me, hold on. It's going to show us this giant JSON object. Well, that's not super helpful. So let's try something here. Let's do a format equals pretty. The JSON object's helpful if you want to stick that data somewhere else. You want to parse it, whatever. That's great, but I don't really want to look at that. And now we have these fun little emojis from the pretty format. We can look through, and we see really the same information here. If I look up and go find my basic demo namespace, we'll see that I'm failing the privilege escalation allowed. So that's a nice, quick, really quick, fast, easy way to get Polaris running locally. And then the last way that we tend to use Polaris is in CI/CD. So maybe you want to, whenever you check in code that has deployment code in it, you want to check these things before you even deploy them to the cluster. You want to get proactive. So there's a few different flags that we can pass the Polaris audit command that will help with that. And I'm just going to talk through them real quick here. So in this case, I'm in the Polaris directory, and there's some test cases that I'm going to run this against. This would be your code that you're testing. I'm going to do the format pretty because if I go look at my logs, I don't want to have to parse through a JSON object. And then we have these other ones that are kind of nice. This set exit code below score. So if my score is below 70 right now, it's going to exit with a non-zero code so that my CI/CD will fail, and I'll get a notification of that, hopefully, in my pipeline. And then we also have the only show failed tests, which just kind of shortens that output for us. So if we go ahead and run that against this particular folder, obviously this one's designed to fail a lot of stuff because these are test cases. And then we can check our exit code, which I think I just messed up by hitting Control-C. But if we were below 70 on our score, we should have failed with a non-zero exit code. And now I'm going to kick it. Actually, I'm going to talk about our next problem. Sorry about that. So one of the problems that we've seen running clusters for dozens of companies, hundreds of clusters over the years that I've worked at Fairwinds, is that one of the biggest problems we always come back to is resource request limits. Resource request limits. Your applications don't have them. You get noisy neighbor problems. You start blowing up nodes and things like that. And so for a long time, we were always asked, well, you say we should set these, but what do we set them to? And so as an SRE, I would have to sit and stare at Datadog dashboards and try and parse out what was a reasonable requested limit to set on a customer's workload. And so I said, there's got to be a better way. I started looking for solutions and discovered the vertical pod autoscaler. And while I'm not a huge fan of running the vertical pod autoscaler in a lot of cases because it doesn't work with horizontal pod autoscaling, it does do one really cool thing in that it has a recommendation engine. So it will watch your workloads over time. It will look at the resources that it's using, memory and CPU, as long as you have the metric server installed, and it will provide a recommendation, a couple different kinds of recommendations to you on where you might reasonably set your resource request limits. And so that led me to develop this project called Goldilocks. What Goldilocks does is it's a relatively straightforward controller. It watches for deployment objects in namespaces that you've labeled as for use by Goldilocks, and it will create a vertical pod autoscaler object in non-update mode or read-only mode for that deployment. And then that VPA object, assuming you have the controller installed, will accumulate recommendations for the containers running in that deployment. What Goldilocks does, in addition to that, so that's the controller portion of Goldilocks, and then there's a dashboard portion that will look through your cluster, grab all those vertical pod autoscaler objects and all the recommendations out of them, and stick them in a nice dashboard so that you can see them all in one place. So I will do a short demo of Goldilocks here. Installation is relatively similar to Polaris. However, the first thing we need to do is actually install the vertical pod autoscaler. So if we look in the VPA namespace in this cluster, I have the VPA recommender and the VPA updater running. There are a couple CRDs associated. We have a Helm chart in our stable repository that allows you to install that. And then I'm going to Helm install Goldilocks from our Fairwinds stable repo into my Goldilocks namespace, just like I did with the Polaris one. And I've actually done this ahead of time. Hopefully what we see, I've been generating some test load and things like that. So if we get deployment in the basic demo namespace, we know we have a deployment. We saw it in the last demo. And then the last thing we have to do is check our namespaces. So if we get namespaces and we look for the goldilocks.fairwinds.com/enabled label, we should see that Goldilocks is enabled in one namespace right now. So I've enabled it in that application namespace that I've been talking about. And so we're going to do another port forward, just like we did with Polaris, but this time to the Goldilocks dashboard. And I'm going to take a look at that dashboard. Now we see we have our list of namespaces that were labeled. We found one here. So I'm going to click on the demo namespace. And we see here we have the namespace. It's got that deployment that we saw. And that deployment has one container in it. We might see multiple containers here as we scroll down if your deployment or each pod in your deployment has multiple containers. And then we're going to see the vertical pod autoscalers recommendations for CPU and memory requests and limits. There's two different kinds of recommendations here. So they're based on Kubernetes quality of service levels. So those are defined down here on the bottom of the dashboard. And there's some nice links out to the documentation in case you want to do some reading on that. And so we see here, my current CPU request is 10 millicores. If we were going to go with the guaranteed QoS route, the VPA is actually recommending we set it to 15. I'm fairly certain that's just the minimum in the VPA settings, but we see that that's less than the recommendation. And here the memory request is higher than the recommendation. So maybe we're setting our requests and limits a little too high. If we didn't have requests and limits, we would get warned about that as well here. And then we have a nice little code block that lets you just copy that resource block out if you want to go stick that straight into your YAML. And over here, we have a range of 15 to 56 millicores, and then the memory is the same in this case. So that's the Goldilocks dashboard. Again, all the recommendations come from the vertical pod autoscaler. So we don't control the recommendation engine at all. It's just a nice way to get a good baseline of a place to start with your resource requests and limits.
Cool. Thanks, Andy. So another big problem we've encountered managing, hundreds of Kubernetes clusters across dozens of clients is that with each new release of Kubernetes, certain resources end up getting deprecated or removed in the newer version of Kubernetes. We saw this in particular, I believe, with 1.16. A lot of resources were removed then, and that prevented us from upgrading to 1.16 until we and our clients took some time to change all those resources in our infrastructure as code. And we found it was very difficult to actually query the Kubernetes cluster to ask it, what resources in here are deprecated. So we built a project called Pluto, which would help us detect these resources. So Pluto can run against your infrastructure as code and look at all the YAML manifests and Helm charts that are there to see if there are any deprecated resources that are sitting in your infrastructure as code. And it can also look into a live cluster for any Helm charts that are there in order to detect any deprecated resources that are in there. This was a huge help for us in migrating to 1.16. It really it gave us a really strong to-do list for what resources need updates before we can actually make that transition. Andy, do you have a quick demo of Pluto?
I do. For sure. So same cluster. We have the demo application running. So say I want to upgrade. So this cluster is running 1.19. We can see that from the get nodes. So I'm planning to upgrade this cluster to 1.20 at some point. So what I probably want to do is just look in this cluster, see if I have any Helm charts that are installed using deprecated APIs. So I'm going to do a Pluto detect Helm, and I'm going to pass this target versions flag, and we're going to target Kubernetes v1.20. Nope, just 1.20. And so we're going to run that. It's going to go look for any Helm releases in my cluster. It's going to pull those manifests, and then it's going to scan through all those manifests and look for deprecated APIs. So I see here I have an ingress object that's using the extensions v1 beta 1 API, which was deprecated a long time ago. And let's see, that's not quite enough information. I kind of want to know, like, when was this deprecated and when is that API actually going to be removed? When is that version going to be taken out of the code base, and when will my stuff start breaking? So we see that the extensions v1 beta 1 ingress was deprecated in 1.14. So I probably should have fixed that a long time ago, but I didn't. And it's going to be removed in 1.22. So I have a little bit of time to get this fixed, but I should probably get on that. So this will work for all of the Helm releases in your cluster across all namespaces. You can target specific namespaces if you only have access to them, or if you have a lot of Helm releases and you want to filter it down. So that's the first usage of Pluto that we have. We use that pretty frequently, especially when we're about to do a major upgrade. The next thing Pluto can do is it can just take standard input. So say I want to template out a Helm chart and see if it has any deprecated versions. Maybe I want to put this in a CI check or something like that. So I actually know that the Helm chart here, the basic demo Helm chart, comes out of one of our incubator repos, and there may be a newer version of this. So let's just do a Helm template of the Fairwinds incubator / basic demo chart. And I'm gonna template that out, and then I'm just gonna pipe that straight into Pluto and use the dash there, and then I'm going to pass that target versions flag again. And let's see if the latest version of this chart that I pull out has any deprecated versions. Looks like it doesn't. It says there's no resources found with known deprecated versions. So it sounds like I really just need to go upgrade this chart to the latest version. And then the last thing that Pluto can do is it can detect files in a repository. So if you have raw YAML manifests or things that you use to deploy your infrastructure sitting in a repository, you can use the Pluto detect files command. We're going to pass that target versions again. Type that. All right. And I'm just going to run that in my current directory here and see what I find. And I'm going to add that S again. Keep doing that. And it looks like I am using a deprecated priority class that we should probably go ahead and update in this repository to the latest scheduling kates.io /v1 API version. There are a couple other output options. So if you do want to take this data and structure it and put it somewhere, we can output it as JSON, which is pretty handy. It'll give you the replacement API, the removed in, all the information that we saw, whether it's been deprecated, whether it's been removed, and then the settings that I passed. So I passed that target versions Kates v1.20. We have a couple of APIs in here that we also look at. We'll look at cert manager APIs as well. And you can actually pass in your own versions list. So if you have CRDs that you're deprecating over time or things like that, you can actually add your own list. And then we can also, of course, it wouldn't be Kubernetes if we didn't output YAML. So that's all the major uses of Pluto.
Cool. Thanks, Andy. So the last problem we want to talk about today is really keeping up to date with your Helm charts. And specifically, I think this is most applicable to kind of those low-level add-ons like Nginx Ingress, Cert Manager, Istio, any charts that you've installed in your cluster as utilities for other applications to take advantage of. Keeping those up to date is really important, to get the latest and greatest features, but more importantly, to make sure that you're staying secure and staying patched so that any bugs or security flaws that have been announced are being pulled in when you pull in those updates. It's an easy thing to leave behind. It's if everything's working, it's hard to really prioritize updating these things. So making sure you at least have eyes on what needs to get updated and are able to prioritize those updates is super important. So the project we built here is called Nova. And what Nova does is it looks inside your cluster to see what Helm charts are running, and then it cross-checks those against public repositories to see if there are new versions available. And if it finds a chart that's been deprecated or that's behind the latest version, it'll let you know, and you can track that to make sure that you get around to that update. We actually use this in two ways. One is to we have a set of basically the target versions that we have for each add-on. We don't always want to be at the bleeding edge of all the latest and greatest features because we want to make sure it's stable as well, but we want to make sure all of the security patches are pulled in. So we have a list of target versions for every Helm chart that we pass to Nova, and Nova checks every cluster that we manage. So hundreds of different Kubernetes clusters get checked against that list to see which of them are out of date, which of them are out of sync with our standards. And then also we will check those standards against whatever's been published latest to make sure that we get notified anytime a new Helm version is available. Andy, do you have a quick demo of Nova functionality?
I do. In fact, I think you just saw a nice little preview of it on my screen there. All right, so again, same cluster, same setup, all the same namespaces. We're going to see a little bit more about what's going on in this cluster because I'm going to scan all the Helm charts in the cluster. I have the Nova CLI installed here. So same thing, written in Go. You can go pull a binary off of our GitHub releases page. And I am just going to run Nova find. Very simple command. So this is going to do a few things. It's going to go find all of the upstream chart repositories that it knows about. It's going to look in the cluster for all of the installed Helm releases, and then it's going to do some version comparison if it can find the chart in an upstream repository. So if we look here, we see I've got quite a few different charts installed. So we have AWS IAM Authenticator, Cert Manager, Cluster Autoscaler, External DNS. We see the version that's currently installed. We see the latest version that we were able to find. And then we see, is it out of date? And has this chart been marked as deprecated? So we do see a couple here that are out of date. Our Ingress Nginx, we could bump a few versions. Our metrics server, we could bump a few versions. Cert Manager is constantly releasing new versions these days, which is great, but hard to keep up with. And then that demo application, which I just talked about needing to update because of that deprecated API version. And then also because of some of the security issues we saw with Polaris, I'm getting yet another reminder like, hey, you really need to go update this chart because it's way out of date and you have some issues here. So there's some additional things we can do here. We can do a Nova find and we can pass a wide flag if we want a little bit more information. And so we see now we've got the release name and the chart name, what namespace it's in, what Helm version was used to install it. I really hope that says V3 everywhere. And then all the same information we saw before. So then Robert talked about another use case that we have for Nova, which is, we don't necessarily want to be on the straight cutting edge of all these charts, right? We want to vet and test and make sure our upgrade paths are clean. Say you were on Cert Manager, what was it, 8 or 0.7, and you really wanted to go to 1.2. Well, that's not something you want to do overnight without thinking about it. It's something you have to plan out. And so what we have is we have a Nova config file. And so if we look here at this Nova config file, we can override the latest version or the desired version of the chart that we want to go to. So we saw that we were on Cert Manager 1. 1.2.1, I think, and then the latest was listed as 1.4, but I haven't tested this upgrade yet. I don't know that it's safe, so I really still want to be on 1.2. And then same with, say, metric server or any of these others. So this is the name of the chart, and I'm going to say these are the versions I want to be on. Couldn't be simpler. We're going to run nova find config nova.yaml, and we're going to just pass it that, and then I'm going to give that wide flag again just because I like all the extra information. And then we're going to run that, and we're going to see that the latest and the old columns change a little bit here. So now we see that Cert Manager, it's still old because I put 1.2.1, but now it's saying I should upgrade to 1.2.1. And same for, let's see, what was the other one we overrode? Don't remember off the top of my head. It's not a big deal. The column changes. It's comparing to the versions that we want. And now we can maintain this standards file that says these are our internal approved standards that we want to stick to. And we can use Nova in a way that's customized to our company instead of just assuming that everybody wants to be on the latest and greatest all the time. Nova has a few other things. It can output to a file if you want to dump that JSON somewhere and do something with it, just like all our other tools. And you'll actually hear about why we do that here in a minute. But that's Nova. Nice and simple, very straightforward tool, but extremely useful to us across the board.
Cool. Thanks, Andy. So open source is super important to us at Fairwinds. We've been a part of the Kubernetes ecosystem almost since the first days of Kubernetes. We've been doing Kubernetes for about 5 of its 7-year lifespan. We really want to give back to the community, and B, just really like the amount of engagement we get with the community when we create open source. People use the tools, they give us feedback, they help us improve the tools, they contribute code back. It's a big part of who we are and what we do is, building our software out in the open. So in addition to these 4 tools, we do have some other tools we do want to highlight today at a little bit quicker of a pace. And we really see them coming into 3 categories. So we have some tools that help you deploy and keep those deployments up to date. So in addition to Pluto and Nova, which you saw today, we have Rocket Scripts, which helps encode CI/CD patterns for really releasing your applications in a GitOps-oriented way. Things like tagging based on commit hashes and branch names. Things like keeping your secrets stored in infrastructure as code, but encrypted. It's a great tool for just establishing really good patterns around CI/CD into Kubernetes. We also have a tool called Reckoner, which helps manage Helm charts. It makes it really easy, especially for those add-ons that Andy was showing earlier, specifying all of those in a single manifest. You can tell Reckoner exactly what you want the cluster to look like, and Reckoner makes it happen. Then once you've got a running cluster, we have kind of our operation tools. We didn't talk about any of these today, but just to go down the list real quick, RBAC Manager really helps simplify how to manage RBAC, easily enough. RBAC is a really tricky concept in Kubernetes, and so RBAC Manager provides a simpler API for managing those roles and bindings. Astro is a tool that we use to basically create dynamic Datadog monitors based on configuration in the cluster. It allows us to basically interface with the Datadog API through Kubernetes so that we don't have to be writing Datadog Terraform, say, in addition to deploying things. We automatically get monitors created in Datadog when we create a new deployment. Gemini is a tool that we have for automating backups for persistent volumes. Typically, it's very tricky to maintain any kind of persistent state in the cluster, so making sure that state gets backed up is super important, and Gemini can help do that. And then we have Sapphire, which is a great and very clever tool for really making sure that you are not vulnerable to issues with your underlying Docker registries. We've had issues in the past where Quay, for instance, might go down, and then any images that we're pulling from Quay, we're not able to really pull into the cluster anymore. So, for instance, our cluster autoscaler image was stored in Quay, and if Quay went down and our cluster tried to scale up, I wouldn't be able to pull those images, and we wouldn't be able to scale the cluster up, basically. So we use Sapphire to basically create redundant copies of those images across different Docker image repositories so that we always have a backup if one of those repositories fails. And then in terms of optimizing, two projects you heard about today. One, Polaris, for just validating those deployment configurations, make sure you're adhering to best practices, and Goldilocks to make sure you're sizing your CPU and memory requests and limits appropriately. So we also have a commercial offering called Fairwinds Insights. Some of this open source is great if you're managing, say, one cluster, or you're just getting started with Kubernetes and want to kind of see what's available. But operationalizing this open source at scale is really difficult. If you've got a whole fleet of clusters, you're trying to deploy this stuff across. If you want to utilize the same configurations across all those clusters, and if you want all those clusters reporting into a single place, it's really hard to make that happen on your own just using out-of-the-box open source. That's true of both our open source and any open source in the wild. Unless you've got a database and some kind of centralized platform that all that open source can report into, it's really hard to really to operationalize it at scale. So we built Fairwinds Insights really as a way for all these tools to report together into one place so you can see all the results there. The 4 tools that we covered today, Polaris, Goldilocks, Nova, and Pluto, all report into Insights. And we've also integrated some third-party tools like Trivy from Aqua Security for doing image scanning. Trivy will detect any CVEs that are running in your cluster and make sure you can see where the critical issues are, where your security issues are, and what you need to patch. We have about 8 or 9 different tools that report into Fairwinds Insights. And again, we basically have built a translation layer so that the findings from all these different open source tools can get collated together and put in a single dashboard so they can be prioritized relative to one another, et cetera.
All right, folks, here is our second poll of the day. What's the greatest opportunity to improve your Kubernetes environment? To get help with the basics, general best practice assessment, implementing the right security configs, saving money, or improving service reliability? This one's going to be interesting. And since I was smacked down in the last one, I'm not even going to try and guess how folks are going to respond to this one. I'm going to give it another couple seconds and let some more responses come in here. All right. I think that is probably just about, oh, no, I'm going to let a few more come in because it seems like people are squeezing them in under the wire. All right, I'm going to close that poll and then we will look at the responses here. All right, so it looks like get help with the basics, 17%, general best practice assessment, 27%, implementing the right security config, 30%, saving money is only 7%, and improving service reliability is at 20%. So I'm going to throw it on back to you, Robert and Andy, and let you talk that through.
Cool. Yeah, that definitely gels with our understanding of the market. I think a lot of the issues that we see our customers facing are really about figuring out how to adhere to best practices and figuring out how to make sure that their clusters stay reliable and stable. That is generally the what ops teams are charged with, is making sure that the app doesn't go down, right? So I think that's very much in line with what we're hearing. Cool. Well, I think we're ready to do some QA, but while we do that, I just wanted to call out we do have a white paper available that I think we can send out a link to after this presentation on 5 Kubernetes security mistakes that you are probably making. Things like granting unnecessary access to the underlying host and making sure that all your containers don't have vulnerabilities, things like that. So this is a great guide to just, if you're interested in Kubernetes security, as 30% of you said you were, I think that'll be a good guide for you.
Very, very cool. And yes, it looks like right there in the chat, folks, is a link to that white paper. So you can go ahead and download it. It's also going to be included in the follow-up email that you get. So if you miss it here, never fear, you'll be able to get that with that email. So, all right. Q&A. Let's see what we got here. First of all, what's the difference between using an open source container scanning solution like Trivy, am I pronouncing that right? Okay. Versus a commercial product like Sneak?
That's a great question. An open source tool can really help you identify, a point in time snapshot of what your security profile is like. So Trivy, for instance, runs on a single container image at a time. It'll report back all the vulnerabilities that are in that image. But once you go with a commercial platform like Sneak or like Fairwinds Insights that can track those findings over time, it can aggregate them into one place. It really helps basically take the core functionality that's available in that open source and operationalize it at scale so that, say, a security team can, in one view, see what are all the vulnerabilities that are in my Kubernetes cluster, and what are the relative severities of those findings, things like that. The open source isn't going to give you that kind of like a bird's eye view into what's going on across your entire organization.
Okay, thank you. All right, let's see, what else do we have? A lot of these tools audit infrastructure as code. Is there a way for me to put them all in my CI/CD pipeline?
Yeah, that's a great question. So each of these tools is available as a binary you can download from GitHub. They take some configuration for each one, et cetera. Fairwinds Insights, the product we mentioned before, actually does package up all of the CI/CD tools into one bundle. You provide one configuration that basically says, here are what Docker images I want to scan. Here are where my configuration files live, those YAML manifests and Helm charts. And then it applies each of those tools to those open source, to those infrastructure as code files that you provided. So it's an easy way to kind of package everything up together and make sure you're getting the results, all collated together.
Okay. All right. Let's see. Get one last question in here. What non-Fairwinds open source tools would you recommend for auditing Kubernetes clusters?
The one we mentioned earlier, Trivy, is a great project from Aqua Security. I think making sure that you are keeping an eye on any vulnerable images in your cluster is super important. So that's probably the one biggest one that I would point out. There are also projects like Sonobui is a great one if you're managing your own control plane and not using a provider like EKS or GKE to make sure that your cluster level configuration is up to snuff. There's other projects like KubeBench that make sure that you are basically in line with the CIS benchmark, which is a set of benchmarks created to make sure that your infrastructure is adhering to best practices. I think we've identified probably in the process of creating Fairwinds Insights 30 or 40 different Kubernetes auditing tools out there in the wild. We've kind of selected the best ones, and or at least each best in class with Fairwinds Insights to make sure that we can cover basically all the use cases. We did a lot of research to figure out which tools were the ones we should incorporate. But there's definitely a lot out there to sort through.
Yeah, absolutely. All right, folks. Well, thank you so much for the great presentation, those awesome demos as well. And audience members, thank you for sending in those great questions. All right. Well, with that, I think it is time for us to do our drawing for the 4 $25 Amazon gift cards. So let's see who our lucky winners are this afternoon. Our first winner today is Eric H. Congratulations to Eric. Next, we have Sarah P. Congratulations, Sarah. Our third winner today is Christian S. Congratulations, Christian. And finally, our fourth and final winner of the afternoon is Danilo O. Congratulations to all our Amazon gift card winners. Thank you so much to our audience for tuning in with us today. Always great to see you. We hope to see you again soon at another DevOps.com webinar. For those of you who are our Amazon gift card winners, sorry, we'll be sending you an email with instructions for how to claim your gift card. So keep an eye on your inbox for that. And if you don't see it there, make sure and check your spam folders. Again, just to remind everyone, the session has been recorded, so you can see me flub this script over and over again. No, really, if you missed any or all of this or any of the demos, you'll be able to go back and watch those again. That will also be included in your follow-up email, so make sure you are keeping an eye out for that. Cool. Thank you so much to Robert and Andy for your time and your energy. And that's it for me. I'm Sharon Florentine, signing off.
Thanks, Sharon.
Thanks.